I've got a job to tomorrow to take the ground source heat pump from the Trend IQ3 controller across to the MAC36NL ISMA controller, and I'm just going to go through the Trend PDF file that I've set up to see what points I need to take across. I naturally need to take sensor 2 across, the ground flow heat pump 1, flow and return 2 and 3. I need to take 4 and 5 across, but I'm going to go down to the bottom of this, if it will let me. And look at a list of all the components rather than looking through the wire sheets. Okay, here we go. Gone too far there. So they're all my sensors. So, sensor 2, flow, heat pump 1, sensor 3, sensor 4, sensor 5. Look for anything else that's ground source. Some DIM modules there, probably got something in on the DIM modules, the DIM 6 modules, but let's just skip through that at the moment. There's a DIM 6.5, here we go. Sensor 60 and 61, it's in KPA. PO652 0 to 5, 0.05 volts, 0 to 5 volts. Okay, so 60 and 61. And the others will be calculated, there's no parts there. So that's what we're going to take across. Not interested in that. Digital ins. Fire alarm. Well, I've got to leave that in that controller because that's controlling the gas boilers, but it would be nice to have a fire alarm. Plant room leak, well, we can leave that in the controller. Pool common alarm. Ground source heat pump circ flow well, I want to take that one across, so that's DI4 flow, ground source heat pumps. Plant room emergency stop, I need to take that well, I'm going to leave it there, but actually I'll take it across Trend network back to the MAC36 controller. So I'll just put DI5 network, and then I can take across 8, 9 and 10 the ground source heat pumps PU. So I could take 8 across, 9 across and 10 across, because that's the source pumps for the ground loop, 9 and 10. So pump A, pump B, and I'm going to take PU across as well. high pressure ground source. Okay, those ones will be not a sensor, they're network. See the NLL1 IC comms. So I can take them myself across. They're using a Modbus to trend synapses device, but I don't need that. I can talk Modbus direct, Modbus IP direct to the heat pumps. Don't need any of that. Yeah, there we go. Ground source heat pump 1 mod comms fail. Well, that's definitely going to be an alarm. I'll have to remove that once I've done it. And there, all the synapses network comms fails, which I'll be going direct to the MAC36NL controller for that. Not interested in any of the knob stroke adjustments, and I won't be interested in any switches because I'll be having my own. These are my outputs, but the ground source heat pumps are controlled via Modbus, so they won't be on there, but the pumps will be somewhere, I should imagine. Here we go. Ground source circ pump A and B enabled. 0 to 10 volts, so 0 to 100, which is 0 to 10 volts. So that will be using a 2RM. I could use a 2RM myself. And just so if I allow for an analog output 1, and we can do exactly the same as that's doing. So ground source heat pumps 1 and 2, A and B, and then ground source circ pump flow fail, number 12. That's an on and an off, but why? So that's going to be a flow switch, but why is it in a driver? I don't know, I'll come back to that in a moment. Maybe it sends a light, puts a light on the panel, which if that's the case, I've got to have that as well. So DL1 is going to be the light circ pump flow fail. Yeah, must be. Let's write that down. Right, then let's look at these DIX modules. Ground source heat pump cooling bypass valve, that's just 0 to 10, and I need them as well. So that's going to be an analog output, and that is heating circuit bypass, and the other one's cooling circuit bypass. Okay, let's go back to these modules. It's going to be right at the beginning, I should imagine. That's network IC comms. There is the DIX modules. So 5, 6, DIM 6, 5, underflow Rain Elverson, Franco. Not interested in that one, they stay the same. 4, booster, no, not interested. Sprinkler, water conditioner, not interested. Foul pump, cavity drain, underfloor pump, no, we're not doing anything with underfloor, not interested in that. So we can forget the 4-1. Dim 3, not interested. Dim 2. Do I want the LPHW PU fault? Well, if I do, I can take it via network, so I'm not interested in that. This would be the one. Ground source heat pump circuit PU fault, so G3. So that's going to be a DI, and it's DI3 on the DIM 6.1. I want that one. And DI4 I want on that for the pump A fault. DI5 pump B fault I want, and 6 is spare. Okay, so what we'll do now is we'll go into the MAC36 controller. I'll load that up now. I'll put you on pause while I do that. Right, I've opened up the station and I've got an inputs folder for the MAC36, and I've got an outputs folder for the MAC36. So I'm now going to populate this with the information we've just took from a trend, and once I've done that, I'll join the dots up and then see where we go from there. I'll put you on pause while I do this. So this is the inputs only, and we've got our 4 temperatures there, 2 for heat pump 1, 2 for heat pump 2, and then we've got our kPa differential on the heating circuit on the ground source side and the cooling circuit, which is what I need. Then from DIM 6.3.1 we've got the PU fault, so I'm going to take that straight from the trend into this controller on the universal input 7. With it being a universal, it can be a digital input as well as a numeric or analog. And then DIM 6.4 pump A fault, DIM 6.5 from the trend, pump B fault. So I'll put these notes here so I know where I'm taking the point from. It's just easier when I'm on site. And then UI10 is ground source heat pump circ flow. So if the pumps are flowing, that's on module 2 of the trend, and point 7, input 7. I've left the MAC36 DIs because these can be used as pulse inputs for counters, and we may need that in future. So at least I can actually bring in 4 pulses into this module without having to buy another module. So there's no point in using them up for normal inputs, for normal binary inputs. Might as well leave them spare and they can be used for future. Now I've got to do the outputs. So I'll get the outputs ready now. I'll put you on pause while I do that. I'll just show you this. I've still got to carry on doing the outputs. But analog output 1 I'm using for the 2RM unit. So 4 volts will put pump A on, and 7 volts will put pump B on. And if I show you the trend logic here, so there's circuit pump A enable, there's the 40, i.e. 4 volts, which should be sent to that. And if it is circuit pump B, it would be 7 volts, or 70 is showing in there, that would be sent to that output there, D. So D equals F when B equals 1. So when that's got an input into it, then D will equal F, which would be 70. Same gate there on that module there, and that's going into the circ pump A and B. D11 is an analog output, so it's 0 to 10 volts, and that is triggered via this circuit pump A and B enable here and here in this logic timers there. So they've got an off delay of 60 seconds in this one, and an off delay in 60 seconds in this one, and this has got a standard trend combi block there giving the output into B. So when you don't have an input there, then so B doesn't equal 1, so D, the output there, is going to be 100, and 100 is basically stop, like a 0 is stop on these 2 RM units. So that's the outputs done. Ground source heat pump 2 RM module, and then 0 to 10 valve analog output 2, 0 to 10 for the heating, 0 to 10 volts analog output 3 for the cooling, and then we've got ground source heat pump 1 cooling flow, D13, D14 on the trend for the return, and heat pump 2 D15 for the flow and D16 for the return. And then ground source pump fail to put a light on the panel. So these are 0 to 10 volts, so 10 volts will open that valve and 0 volts will close it. And then these are 0 to 10, so anything between 0 to 10 volts to open the bypass. And then we already know that that is 4 volts to run pump A and 7 volts to run pump B. 0 volts turns them off. So I've got to put these points into the logic, but first of all I need to now do the Modbus from the ground source heat pump 1 and 2. So I need to know where I've got a folder here for inputs and outputs. I need to make another folder for the network to the Modbus for sending information and for receiving information from ground source heat pump 1 and 2. So I'll probably make a folder called Modbus, and then under that another folder ground source heat pump 1, and do all the points for that, and then I can then just duplicate that folder for ground source heat pump 2. So that's my next job, and I'll just show you up here the ISMA module in case no one's seen a MAC36 with the built-in points. I'm just going to show you for adjusting the points. Let me just put that into a wire sheet. Because these are universal input points 1 to 16. So as you can see, we've got these 4 temperatures here. So I'll just open one for you. And that's set to 10K 3A1. It'll drop down. You can have it voltage, current, digital, resistance, or then you got your different temperature sensors that you can select, or a custom table. Well, we're just using 10K 3A1. Now if you use PT1000s, you change that 12-bit to 16-bit, but otherwise you just leave it at 12-bit on them all. Let's go back. Do I want to save? No. So if we look at a voltage, So that's just a voltage 1, so it's getting an input 0 to 5 volts on this particular, so that's set to voltage, as you can see. And these are just set to digital output. I know it's a numeric point, but 0 is off, 1 is on, and they're set to digital inputs. Right, I'll start with the Modbus now. I'll put you on pause. So I decided to just have one folder for the ground source heat pumps because there weren't that many Modbus points. I don't know what the addresses are yet. I'll find that when I go onto site. But the ground source heat pump 1 is high pressure, thermal alarm compressor 1, thermal alarm compressor 2, flow alarm, heat pump alarm, and Modbus alarm, the IC comms or the comms alarm, network alarm. And then for the outputs, we've got enable the ground source heat pump via the BMS, because apparently it needs that. But again, I'll check it when I get to site. And then we've got the reset the ground source heat pump, so we can send a reset alarm. I've just used a single one shot there. And then enable ground source heat pump 1, which will be tied into my logic. The mode for ground source heat pump 1, whether it's heating or cooling mode. And enable ground source heat pump 2. That's just via Modbus to the ground source heat pumps. Naturally, we're doing the hardwired ones for the pumps to enable the circulation, the ground source circulation pump to run. So that's it for now, until I get to site. If you don't know what a MAC36NL controller is, because you may have not looked at other videos, let me just put you on pause and bring up a data sheet for you. Here's a picture of the MAC36 controller. You can see the universal inputs at the top, UI 1 to 16. You got your 4 digital inputs, which can also be used as counters. And then at the bottom left hand side, you've got analog output 1 to 7, and you've got digital outputs 1 to 8. This one that I'm showing you has got 2 COM ports, so it's got COM port 2, and then it's got COM port 1. There's your COM port 2 next to your HDMI, and up at the top right will you be your COM port 1, if it will let me get, you can see that. Yeah, it's just coming there. That's your COM port 1 up at the top. Let's have a look at another view. So you've got your 2 Ethernet ports, and then you've got your power supply here, 24 volts, AC or DC. What that picture shows. Your SD card, backnet, Modbus, MBus, so you can get an MBus model of this. 2 RS485s, 2 USBs, HDMI, 36 IO, hence the MAC36. So that's on the bmsparts.co.uk website. I like that controller, it's a good controller, especially with the built-in IO. Okay, I think that's it for now. Have a good day.